Today we're going to talk about imaginary and complex numbers and how to add and subtract them. So you're probably looking at the word imaginary and wondering, what in the world are we actually talking about? I was just getting used to variables. Well, up until this point, you could not solve a square root that had a negative number under it because that was an impossibility. Because any number, when you square it, whether it is positive or if it's negative, when you square it, the answer is always positive. So there's no such thing as the square root of a negative number. So what Algebra 2 does is we assign a value to the square root of -1, and that value is I, which is the imaginary number. This allows us to pull the square root of -1 out of the problem and then solve it the way we did in the past lessons. Square root of -1 is I, and then I can break down 216 so that I can find out what comes out of the radical and what stays inside. Since 216 is an even number, I'm going to start by dividing by 2. I'll continue with 2 until I can't use that anymore. Now I need to divide by 3. Once I've broken down this number and gotten down to the point where it's just the number and 1, I know that I have all the prime factors of 216. And I'm looking for anything that shows up twice. Whatever I have circled gets to come out of the radical. So since I have both a 2 and a 3, they're going to multiply together and come out and multiply with the I that's already on the outside of the radical. The numbers that are left inside are 2 and 3. They're also going to multiply back together. So my final answer is 6I square root of 6. I'm going to let you try number 2. Remember, pull the -1 out, assign it the value of I, and then break down the 320 just like you did in the previous lessons. All right, so moving on down to number 3 and 4. In these problems, we're going to combine like terms. And I want you to focus on the fact that I functions exactly as any other variable would. When we're wanting to combine like terms, the first thing that we need to do is get rid of the parentheses. If there isn't anything in front of the parentheses, we can just go ahead and drop the parentheses. In this case, there's a negative in front of the parentheses, so we need to distribute the negative to each term inside of the parentheses. That's going to give us a -1 and a positive 5i. Now that we have gotten rid of all of our parentheses, we can combine the like terms. A -3 can be put with a -1, and since they have the same sign, we add them and keep the sign. We get -4. Positive 7i and positive 5i can be combined. We only add the coefficients. The I remains the same. So that gives me positive 12i. This is my final answer, but there's one more thing I want to talk to you about. Complex numbers are typically written in a specific order. The real part of the number is written first, and the imaginary part of the number is written second. So it's a good habit to get in writing your numbers in this order. Now I'm going to let you try number 4. All right, these last 4 problems all have I raised to a power. One of the things you need to know is that there are 4 values of I. And there's only 4 values of I. So I'm going to write these down. The 4 values are I, -1, -I, and 1. I've had some people say you could remember it by saying, I won, like you're cheering for yourself because you've done a great job. There's lots of different tricks you can use, but you do need to memorize these 4 values of I. These values come from raising the square root of -1 to a power of 1, a power of 2, and so forth. So this is I to the first power, I to the second power, I to the third power, and I to the fourth power. When you're given a value of I to the 33rd, you could literally count your way to the value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and continue. But that could take some time. So there is a shortcut. Since there are 4 values of I, you can take the exponent and divide it by 4. The remainder will tell you the answer. 4 goes into 33 8 times with a remainder of 1. So this is how it works. A remainder of 1 is the first value. Remainder of 2 is the second value. Remainder of 3 is the third value. And if it divides evenly and has no remainder, then it's number 4. So the answer to number 5 right here, I to the 33rd power, is remainder of 1, which is I. In number 6, you're going to need to remember your exponent rules. If you have 2 variables or 2 bases that are the same, you can add the exponents together when they're multiplied. So this is actually I to the 14th power. Now that you've added these exponents, you can divide 14 by 4. 4 goes into 14 3 times with a remainder of 2. So I to the 14th power is -1. I'm going to do one more example, and then I'll have you try number 8. In number 7, these variables are not multiplied together, so we cannot use the exponent rule where we add up the exponents. This time we're going to have to solve each of them individually and find out what their values are. The first one, 21, if I divide it by 4, 4 goes into 21 5 times with a remainder of 1. Remember, my values of I are I, -1, -I, and 1. So a remainder of 1 is I. So I'm going to write that down. For the second one, 38. 4 goes into 38 9 times with a remainder of 2. Remainder of 2 is -1. Don't forget, there was already a negative on the in front of that number, so you actually have -1. I to the 12th. 12 divided by 4 is 3 with a remainder of 0. A remainder of 0 is our fourth value, 1. So now that I have rewritten these 3 i's with their new values, I'm also going to take this negative and make it a positive. And now I can combine like terms. So I have I plus 2. This is a final answer, but it's not in the correct order. Remember, I told you earlier that when I'm writing a complex number, I need to put the real part first and the imaginary part second. Okay, it's your turn. I'd like you to try number 8.